Now, in stars which are around about 1.3 times more massive than our sun, or heavier, the proton-proton chain is not actually the major way of producing energy. Rather, these stars will work off the carbon-nitrogen-oxygen cycle. Now, the carbon-nitrogen-oxygen cycle isn't just one cycle. There's a whole range of different cycles which can take place depending upon the temperature and the relative abundances of the different elements within the sun that we're considering. So here we'll just consider one example of the carbon-nitrogen-oxygen cycle. So with the carbon-nitrogen-oxygen cycle, it doesn't actually use up the carbon, nitrogen and oxygen involved. Rather, these are catalysts. They're needed for the reactions to take place, but then they're released again at the end. Okay, so let's start with carbon-12. This can combine with a proton to give us nitrogen-13 and a gamma ray. The nitrogen-13 is then unstable and decays into carbon-13 through a beta plus decay, so it also produces a positron and an electron neutrino. Now, that positron immediately combines with an electron, releasing two gamma rays. The carbon-13 then combines with another proton to produce nitrogen-14 and a gamma ray. The nitrogen-14 combines with another proton to produce oxygen-15 and an additional gamma ray. And then the oxygen-15 is unstable, so undergoes beta plus decay to produce nitrogen-15 as well as a positron and an electron neutrino. And the positron then annihilates an electron, producing an additional two gamma rays. So the nitrogen-15 then meets a proton and they combine to form carbon-12 and the helium nucleus, the alpha particle. And now we've got the carbon-12 back, which is what we started our cycle with. So the overall equation for this cycle, cancelling out everything that appears on both the left and the right, and remembering our annihilation of the positrons with the electrons, is that we have 4 protons combining with 2 electrons, and we end up with one helium atom, helium-4, as well as 2 electron neutrinos and 7 gamma rays. We also have a lot of energy released due to the mass difference in the E = mc squared. So in this process, we're releasing 24.7 mega electron volts of energy.